Okay, in this video, we're going to go over all of the quizzes questions on right triangle trig. So the first one says, what is the correct setup for the problem to find the measure of the indicated angle? So from this angle's perspective right here, is the adjacent at 28, and this is the hypotenuse. So SOHCAHTOA reminds us that if we have adjacent over hypotenuse, we can use cosine. So the cosine of the angle is going to be adjacent, which is the 28, over the hypotenuse, which is the 41, and therefore this is the correct answer. So it would be C. Okay, moving on. If you are given the two sides, that are not the hypotenuse, okay, so sides that are not the hypotenuse, which trig function should you use to solve for the missing acute angle? So if you're given two sides that are not the hypotenuse, look up here, you're going to use tan, because tan uses opposite and adjacent. It's the only one that doesn't have the hypotenuse in it. So your answer is going to be to use tan. Find the length of side Y to the nearest hundredth of a centimeter. Okay, so let's look at this. And it looks to me, if I want to find sine Y and I have the 17-degree angle, side Y is across from the hypotenuse. Across the right angle, therefore it is the hypotenuse. If it's the hypotenuse, figure out what you have at 73. That's touching the angle, but it's not the hypotenuse, so that is the adjacent. Okay, so with adjacent and hypotenuse, let's write SOHCAHTOA once again. SOHCAHTOA, I see I have adjacent and hypotenuse, so that looks like cosine. So I'm going to say the cosine of 17 equals adjacent is 73 over hypotenuse, which is y. So now you're going to do your cross products. Let me just move this up a little bit. Okay, so doing cross products, what do I get? I get y times the cosine of 17 equals 73. Y is going to be 73 over the cosine of 17, and that should go in your calculator. Remember, you have to be in degrees, and 17 divided by the cosine of 73 divided by the cosine of 17 should give you 73.64. So check that with your own calculator so that you know that you are getting the right answer. Don't just copy down my stuff. Okay, next one. What is the length of side X to the nearest hundredth of a centimeter? So side X, look where that is. I've been given one angle. What angle do you have? You're given the 28. Across from the 28 is the opposite. Touching the 28 but not being the hypotenuse is the adjacent. So you're going to say, SOHCAHTOA, I can write right here, and you should be writing this all the time. SOHCAHTOA tells me that if I have opposite over adjacent, I can use tan. So the tan of the angle given, which is 28 degrees, equals opposite, which is the x, over the 14, which is the adjacent. Okay, do your cross products. It's a one-step problem. 14 times the tan of 28 equals x. And if you do 14 times the tan of 28, you should be getting 7.44, which is right here. So that should be your answer. Okay, moving on to number 5. So number 5 says, find the measure. Remember that M says measure of angle N in degrees. Okay, let's figure out where angle N is. It's right here. I've been given two sides. This side across from it is the opposite, this side touching it, but not across from the right angle, is the adjacent. I'm writing SOHCAHTOA again. I should see this all over your paper as well. And because I have opposite and adjacent, I'm going to use tan. So my setup is this. The tan of angle N equals opposite, which is 24, over adjacent, which is 6. Therefore, N equals tan to the -1. Remember, you use inverse trig of 24 over 6, and you should be getting that that is about 76 degrees. So angle N is 76 degrees. Okay, moving on to 6. Find the length of side W to the nearest tenth of a centimeter. Okay, so you need to find W, which is right here. Here's the angle that you've been given. That is the opposite. And next to it and across from the right angle is the hypotenuse. So SOHCAHTOA tells me opposite and hypotenuse, I'm going to use sine. So the sine of 40 degrees equals opposite, which is the W we're looking for, over the hypotenuse value, which was 28. So this is a one-step problem. Doing cross products, I get 28 times the sine of 40 equals W, which is exactly what I want. So W ends up being 18. So right here, 18, and it's in centimeters because they gave me units, so I have to give them back units. Okay, I'm doing this pretty quickly, but you can stop the video at any time so that you can think it through, and it's a really good idea to see if you can work the answers along with me. Stop before I tell you the answer and see what answer you can get. That's the best way to use this video. Listening to it or doing it while listening to music is not the way to do this video. Okay, number 7. Find the measure of the indicated angle and round to the nearest tenth of a degree. So if this is my angle right here, what should I do? Well, I should figure out what they've given me. This is the opposite, and this is the adjacent. And write this as many times as you need. If I have opposite and adjacent, that is going to be tan. So the tan of some question mark equals, opposite is 34 over 39. So what does this angle equal? Tan to the -1 to get back an angle of 34 over 39 gives me 41.1. Okay, I'm going to do that and highlight it so you can see the letter. So that's what that gives me. Okay, next one, number 8. Find the measure of the indicated angle and round to the nearest tenth of a degree. So this is also a chance to practice rounding. All right, here's the angle. So that is opposite, and this is across from the right angle. So that's going to be hypotenuse. And SOHCAHTOA tells us that when we have opposite and hypotenuse, we're going to use sine. So here's your setup. The sine of the question mark angle equals 23 over 28. Okay, that's your trig ratio. Now let's get the angle by using inverse trig. Okay, if you put this in your graphing calculator, for number 8, you should be getting 55.2 when you round to the nearest tenth. Okay, so 55.2. Moving on to number 9. Number 9 tells us that we have to solve for x and round to the nearest tenth. So look where x is. X is this side right here. So here's the angle that we've been given. So that side of 23 is touching it, but it's not the hypotenuse. So that's the adjacent. The x, however, is the hypotenuse because it's right across from the right angle. So if I have adjacent and hypotenuse, Adjacent and hypotenuse is cosine. So my setup is this. Cosine of the angle that's given, which is 63 degrees, equals adjacent, goes on top, over hypotenuse. Do your cross products and you're going to get x times the cosine of 63 equals 23. To get x by itself, you're going to divide both sides by cosine of 63. So x is going to be 23 over cosine of 63. Okay, when you put that in your calculator, you should be getting 50.7. Right here is where you should be. Okay, and it is a side length, and they gave me no units, so I don't have to give them back any units. All right, next one, number 10. Solve for the missing angle and solve to the nearest degree. Okay, so we're going to do it to the nearest degree. Here's where the missing angle is. They're just calling a question mark. I'm going to do the same. This is adjacent. This is hypotenuse. Katoa tells us if we have adjacent and hypotenuse, we are looking at cosine. So the cosine of this question mark angle equals 13 over 18. Therefore, this angle, when I use inverse trig, is going to be what? So number 10, you should be getting 44 degrees. Because I got, for the question mark angle, I got 43.7. But they say they want it to the nearest degree. If they want it to the nearest degree, I'm going to report that as 44 because the 7 in the decimal position makes the 3 go up to 4. So that's why 44 is our best answer. All right, now we have some word problems. So a yacht is anchored 90 feet offshore from the base of a lighthouse. Okay, so that's what you have. The angle of elevation. Now remember, this is the angle of elevation right here. From the boat to the top of the lighthouse is 26 degrees. The distance between the yacht and the top of the lighthouse is about 100 feet. So the distance between the yacht and the top of the lighthouse, so that's here. So that's about 100 feet. Which of these is nearest to the height of the lighthouse? Okay, so we want the height of the lighthouse. So I have some options here. I could do Pythagorean theorem and solve for it, or I could use trig. I think I'm just going to use trig. The height of the lighthouse is, I put the letter H, but that H does not stand for hypotenuse, right? This is the opposite side. This is the adjacent. So Katoa tells us if we have opposite and adjacent, and that's what I want to use here, I'm going to use tan. So my setup is this. The tan of 26 degrees equals H, which is unknown, over 90. So if you go in your calculator and you say 90 times the tan of 26, you're going to get 43.9. So I have 43.9 because I did this as a one-step problem. My cross multiplication, cross products gave me this. Now they say, which of this is nearest? So which of these answers is nearest? Well, none of them is exact, but they're not asking me for the exact. So the nearest is going to be 45 feet. Okay, now you could have done this by doing other ratios. You could have used sine. So let's see what happens if we did that. What if we use sine? We use sine, we would have said the sine of 26 equals H over 100. What do you get if you say 100 times sine of 26? 100 times the sine of 26. There I get also 43.8 now, so it's slightly different, but that's still the right answer. What if I did Pythagorean theorem instead? And I said 100 squared, because that's the hypotenuse, equals leg squared plus leg squared. What happens then? Well, to get h squared by itself, I'm going to have to subtract 90 squared from each side, and I want just plain old h, so I will put this in my calculator. Second square root of 100 squared minus 90 squared, and what do I get? I get 43.58, which is 43.6. So here, oops, so sorry. Here, h equals 43.6, which is closest to 45. So I just did this problem 3 ways. Now, you don't have to do it 3 ways, but it was a good opportunity to go over the different options you have when solving for right triangles using SOHCAHTOA and using Pythagorean theorem. Okay, so here's another one, another word problem. You have to provide the picture. So it's a right triangle. So draw a right triangle first, and then figure out the problem and the setup. Okay, a 16-foot ladder leans against a building. That means this is 16 feet. That's my ladder. Okay, leans against a building. That means this is my building. Okay, right there. If the angle the ladder makes with the ground, so angle and ground, so here's your ground. If that angle is 68, it means it goes right here. That's your 68 degree. How high up the building does the ladder reach? So I want to know this x. How far up the building does the ladder reach? So let's see what I have. I have the opposite, this x that I need is the opposite, and they gave me the hypotenuse, and they gave me the angle. So opposite and hypotenuse, SOHCAHTOA, opposite and hypotenuse, you should be saying use sine. Sine of 68 degrees equals opposite, which is x, over 16, that's a one-step problem, so 16 times the sine of 68 equals x. Put that in your calculator and you should be getting an answer of 14.8. So this is your answer right here. Next problem. Susan is flying a kite which gets caught in the top of a tree. Use the diagram to estimate the height of the tree. Okay, so right here, that's your tree height. So I'm going to say this is your tree height, and that's what we need. They gave you the angle of 44. This side is adjacent, this side is opposite. So if you think about SOHCAHTOA, and we write it down again, opposite and adjacent is going to mean we're going to use tan. So the tan of 44 equals, we'll just call it tree, over adjacent, opposite over adjacent, which is 90. That is a one-step problem. So in your calculator, you would say 90 times the tan of 44 and see what you're going to get. So go ahead and do it right now. Don't wait for me. Okay, what did you get? You should have been getting 87. Okay? All right, Jake built a skateboard ramp that covers a horizontal distance of 10 feet. The ramp rises a total of 3.5 feet. What angle does the ramp make with the ground? Round to the nearest degree. Okay, so first off, you've got to understand what this looks like. Everything's going to be right triangles. So if you start out with a right triangle, that's going to help you. He built a ramp. Okay, so here's our ramp. So it says the ramp rises a total of 3.5 feet. Well, that must be the rise is here. Jake builds a skateboard ramp that covers a horizontal distance of 10 feet. So that means that the horizontal distance is from where it starts to where it ends. That's the horizontal distance is on the horizon. So we're okay with that. Now they say, what angle does the ramp make with the ground? Okay, your ground is here. This is the ramp. So they're looking for this angle. We'll put a question mark in here. So I have the opposite and I have the adjacent. So SOHCAHTOA tells us if we have opposite and adjacent, we're going to use tan. So the tan question mark equals 3.5 over 10. So to get your angle, you're going to say tan to the negative 1 of 3.5 over 10. And what do? If we put that in our calculator, you're going to get an angle, and we called it question mark. Oops, sorry. We call that angle question mark. So my question mark is going to equal 19.3 degrees. If you're going to round that to the nearest degree, that's going to be 19 degrees. Okay, up to 15. Solve for this missing distance. So what's missing? This D right here. That's what's missing. So I have an angle. The distance is opposite. The 30 meters is the hypotenuse because I'm assuming this is a right angle and that's across from it. So if I need to get opposite and I've been given hypotenuse, then I should be using sine. So the sine of that angle equals the distance I'm looking for over the hypotenuse I was given. Do your cross products. D is going to equal 30 times the sine of 39. When I put that in my calculator, 30 times the sine of 39, I will get 18.9. Okay, just a couple more. So here comes 16. Spencer is going snowboarding. He rode the ski lift to the top of the mountain, which is at an altitude of 1,500 feet. Okay, so start drawing. So I need a right triangle, right, because this is all right angle trig. So here's my triangle, here's my right angle. He rode the ski lift to the top of the mountain, which is at an altitude, so that means straight up, of 1,500 feet. The angle of elevation from the bottom to the top of the mountain is 25 degrees. Remember where your angle of elevation goes. What is the length of Spencer's run, his trip down the hill? Well, here's the hill, right? So they want to know, what is that? So from this angle's perspective, I have the opposite and I need the hypotenuse. Opposite over hypotenuse is going to be sine. So I'm going to say the sine of 25 equals 1,500 over x. Now that's going to be a two-step problem. First step, cross products, x times the sine of 25 equals 1,500. Next step, divide by that, put 1,500 divided by sine 25 in your calculator, and you should be getting a very big number. So you should be getting 3,549.30 feet. Okay, here's another one. They gave you the picture this time, so we're just going to use the picture and analyze it. Solve for the missing angle. So they've given you the opposite and they've given you the adjacent. So that sounds like tan to me. Okay, so I'm going to say the tan of angle X equals opposite over adjacent. Remember, to get your angle, you're going to say tan -1 of 300 over 400, and the angle that we get is going to be 36.9 degrees. Okay, we're just about there. We've got just a couple more to go. Okay, a pilot looks down and sees the runway at an angle of depression of 10 degrees. Okay, so now that's a good problem because we are dealing with an angle of depression, and sometimes that can be confusing. So here's where the pilot is. He looks down and sees the runway at an angle of depression that is right here of 10 degrees. If the horizontal distance between the plane and the runway, that's this distance right here, is 8,000 feet, what is the height of the plane? So we need to find the height of the plane because the plane is up here, which is x. Okay, remember, this line of sight is parallel to the ground. This hypotenuse is acting like a transversal. Therefore, the angle of depression equals the angle of elevation. That lets me put the 10 degrees inside the triangle. So then from 10 degrees perspective, this is the opposite and this is the adjacent. So SOHCAHTOA tells me opposite over adjacent is tan. So the tan of 10 degrees equals x over 8,000. That's a one-step problem. 8,000 times the tan of 10 degrees should give you an answer of, that's going to equal x for one. Oops. Okay, that's going to equal x, and my x is going to be 1410.6. That equaled what my x was. Okay, two more problems. Which scenario describes the picture shown? A 5-foot ramp is 8 feet away from a building. Okay, so the ramp is going to be here. Okay, so that can't be it. Okay, a 5-foot ramp leans against an 8-foot structure. That doesn't seem right either. So I'm going to say no for that too. An 8-foot ramp, oh, that sounds more reasonable. Because remember, the ramps are always at an angle. So that's going to tip you off that could be true. The ramp is 8 foot and it leans against a building 5 foot away. That sounds more reasonable. So I would say that the best case scenario is this one, but let's just check this part D, or number D. A 5-foot man is 8 feet away. Nope, makes no sense. Okay, so the best answer, and really the only reasonable one to describe that scenario, is C. Okay, we made it. Last problem. A traffic helicopter spots 2 different accidents. One is east at an angle of depression of 35 degrees. The other is west at an angle of depression of 21 degrees. So that's tough. So here is my helicopter. Here is the horizon. Here is the ground. So from the helicopter's perspective, there's an accident that's east. East is this way. The angle of depression is what? One is east at an angle of depression of 35 degrees. That is 35 degrees. Other is west. So this is one accident. This is the second accident, and its angle of depression is 21 degrees. if the helicopter is 800 feet in the air, okay, so that's a good number. So that's here. So here, because this is your helicopter, so it is 800 feet in the air. Okay, what can we do with this? So they want to know how far apart are the accidents. So this is a right angle. From this point to this point will be x. From this point to this point will be y. Remember that the angle of depression can become an angle of elevation. Angle of depression can become an angle of elevation. So it looks to me that if I do, this is always going to be opposite, and this is going to be adjacent. I can do two tan problems. The tan of 21 equals 800 over y. So two-step problem. Divide by tan 21. Divide by tan 21. So y is going to equal 2084.1. And then do your other problem to get x. And I'm going to say the tan of 35 equals 800 over y. So two-step problem again. Over x. Okay, change this to x. Yep. Change this to my x. And I'm going to not write it out, but you should be able to do this also. And you should be getting x is 1142.5. Add these two numbers together. So we're going to add this number and this number to get how far apart the accident is. And you should be getting 3227. And that finishes this whole packet. So go back, make sure you understand this, and review it one more time because there's lots of really good problems here.